Students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing the chapter called as network analysis. Let's see a sum, guys. We'll see example 5, page 375. I'll write the question down. You have activity 1 to 2, 1 to 3, 2 to 5, 2 to 4, 5 to 6, 4 to 6, 3 to 6, 6 to 7. They've given you time estimates in week. There are 3 times optimistic time, most likely time, and pessimistic time. The time given to you is 135, then 246, then you have 357, then you have 567, then you have 579, then you have 6810, then you have 7911 and 234. Right? Now I need to make a PERT network for this. If I have to make a PERT network, the first thing I have to do is I need to make a time estimate table, right? So the first thing I need to make is a time estimate table activity 1 to 2, 1 to 3, 2 to 5, 2 to 4, 5 to 6, 4 to 6, 3 to 6, 6 to 7, right? Now, most you have, first thing that you have to do is get the expected time. Expected time is given by the formula TE is A plus 4M plus B upon 6, right? Now, where A is nothing but my optimistic time, M is most likely time, B is pessimistic time, right? So in the first case, this is going to be 1 plus 4 into 3 plus 5 upon 6, 12, 13, 13 plus 5, 18, 18 upon 6, that's going to give you this is 1 plus 3, this is going to be 3, right? Next, the next thing that you have is 2 plus 4 into 4 plus 6 upon 6, 16, 22, 24 upon 6, 6 4s are 24. Next you have is 3 plus 4 into 5 plus 7 upon 6, 4 5s are 20, 30, 30 upon 6, 5s are 30. Next you are going to have 2 to 4 is 5 plus 4 into 6 plus 7 upon 6, 6 4s are 24, 24 and 5, 29, 29 and 7, 36 upon 6, that is 6. Next you have 5 to 6, so this is going to be 5 plus 4 into 7 plus 9 upon 6, 7 4s are 28, 37, 37, 42, 7 6 are. Then you have 4 to 6, that is 6 plus 4 into 8 plus 10 upon 6, 4 8s are 32, 42, 48, 6 8s are 48. Then you have 7 plus 4 into 9 plus 11 upon 6, this is 36, 36, 47, 47, 54, 54 upon 6, 9s up. And last is 2 plus 4 into 3 plus 4 upon 6, 4 3s are 12, 12 plus 4, 16, 16 plus 2, 18, 18 upon 6, that is 3. Then next thing you have to do is find out standard deviation. Now, how do I find out standard deviation? Standard deviation is given by the formula b minus a upon 6, right? Now, b minus a upon 6, this is going to be 5 minus 1, 4 upon 6. Don't do the cancellation because I need this common denominator somewhere later, right? Next, 6 minus 4 or 6 minus 2, that's again going to be 4 upon 6. Then you have 7 minus 3, which is again going to be 4 upon 6. Then you have 7 minus 5, which is going to be nothing but 2 upon 6. Then you have 9 minus 5, 5 to 6, 9 minus 5, which is going to be 4 upon 6. Then you have 10 minus 6, that is again 4 upon 6. Then you have 11 minus 7, which is going to be 4 upon 6. And 4 minus 2, that's going to be 2 upon 6. Once you get standard deviation, then you find out variance. B minus A the whole square upon 36. Now, b minus a the whole square is going to be nothing but 16 upon 36. All I need to do is just square these numbers. This is again 16 upon 36, 16 upon 36, 4 upon 36, 16 upon 36, 16 upon 36, 16 upon 36, and 16 upon 36. So thus my estimate timetable is made. Once the estimate timetable is made, then the next thing that you need to do is make network diagram, right? Network diagram.
Sir,
Yeah.
so last is 4.
4 by 36, right? Next, let's move on ahead. Network diagram. You have event 1. From 1, you have 1 goes to 2. And 1 goes to 3, right? 1 to 2, the expected time is 3 weeks. 1 to 3 expected time is 4 weeks. We will call this as activity A and we will call this as activity B. Then 2 goes to 5. 2 goes to 5. We will, the time is 5 weeks. We will call this as activity C. Then 2 goes to 4. 2 goes to 4. The time here is 6 weeks. We will call this as D. Then you have 4 goes to 6. Now before that we did 2 goes to 4. Then you have 5 goes to 6. 5 goes to 6, we will call this as activity E, which is 7 weeks. Then you have 4 goes to 6. 4 goes to 6, we will call this as activity F, which is 8. Then you have 3 goes to 6, which is activity G, which is 9 weeks. And then you have 6 goes to 7. Right, which is H mu, that is 3 weeks. So that's my network diagram. Once my network diagram is ready, let's calculate the various paths and the duration. The various paths that I have is A, D, F, H. Then I have A, C, E, H. Then I have B, G, H. These are the 3 parts I have. Duration. Duration is 3 plus 6 plus 8 plus 3. This is 12. 12 and 8, 20 weeks. Next, you have 3 plus 5 plus 7 plus 3. 10, 15, 18 weeks. Then you have 4 plus 9 plus 3. 12 and 4, 16 weeks. The maximum duration is for the path ADFH. That means this is going to be my critical path. So now I can say that critical path is going to be nothing but ADFH, right? Normal project completion time. Normal project completion time is 20 weeks. Variance. Now when I say variance, I have to consider variance of critical path. If I consider variance of critical path, right, 1 to 2, variance is 16 by 36. Then you have ADFH, right, 2 to 4, variance is 4 by 36. Then you have 4 to 6, variance is 16 by 36. And finally 6 to 7, variance is 4 by 36. 36 is the common denominator. Add all the numerator, 20 plus 20, this is going to be 40 by 36. So 40 by 36 is going to give you, if I do this 40 by 36, this is going to come to 1.11. So my variance is going to be 1.11. Standard deviation is square root of variance, square root of 1.11, which will come out to 1.05 weeks. So now my sum is ready for PERT analysis. Okay. Now the first part, they said that we've already done the chart. If 21 week deadline is imposed, 21 weeks deadline is imposed, right? Now if 21 weeks deadline is imposed, first of all I need to get my normal distribution variable Z. How do I calculate my normal distribution variable? Normal distribution variable is given by the formula due date minus expected date upon standard deviation. Due date, I want the project to be completed in 21 weeks. The normal project completion time is 20 weeks. Standard deviation is 1.05. So this is 1 upon 1.05. So my normal distribution variable is going to be 0.95. Right? Normal distribution variable is going to be 0.95. Now let's draw the bell curve for this. Right? Now we know that each half starting from the center is 0.5. This area is 0.5. Area under curve on each side is 0.5. Now I want, this is TE is 20 weeks. I want 21 weeks, right? 21 weeks is going to be ahead here. So your time is 21 weeks. The normal distribution variable on the curve for 21 weeks you have found out is 0.95. The normal distribution variable on the bell curve for 21 weeks you have found out is 0.95. Now if you look at your normal distribution table, for 0.95, the area under curve is given to you as 0.95, 0.3289. This area is given to you as 0.3289. You have your normal distribution curve 0.9, and then in the columns you see the fifth column you will get your area, right? In which case I can therefore say that the area under the probability that the project is going to be completed in 21 weeks is going to be the area under curve, that is 0.5 plus 0.3289. 0.3289. So that is going to be 0.8289. So the project will be completed, the probability that the project will be completed in 21 weeks is 0.8289. If I have to represent this in terms of percentage, I have to multiply this by 100. So this will be 82.89%. So the probability that the project will be completed in 21 weeks is 82.89%. Fine, do we get this thing clear? Next, let's see another part of the question. You want 99% assurance that the project will be completed on time. Want 99% assurance that project completed on time. Right? That means my probability that project completed on time is 99%. If I have to represent this in terms of fraction, I have to divide by 100. So this is going to be 0.99. So probability that the project will be completed on time is 0.99. What does this 0.99 indicate? It indicates the area under curve. Let's draw the bell curve and understand this, guys. Right? What does 0.99 indicate? It indicates the area under the bell curve. Now, this is my time with TE, which is 20 weeks. My critical time is 20 weeks. Now, out of 0.99, we know that each half of the bell curve is 0.5, right? So, in that case, I can therefore say that this is going to be, this area is 0.5. The total area that I want under the bell curve, let's assume that my normal distribution is here. The total area that I want under the bell curve is 0.99. Therefore, what will be the area of the bell curve ahead of the mean line? The area of the bell curve ahead of the mean line is going to be 0.49. Guys, here I know the area and I want to find out the variable. In the previous case, I had the variable, I had the normal distribution variable and I had found out the area. Right? Now for 0.49, the closest I can get to 0.49, the closest I could get to 0.49 is 0.4901, which is 2.33. So the normal distribution variable here is going to be 2.33. For 99% assurance for P project completed, for probability of project completed with 99%, Z is going to be 2.33. But we know that Z is equal to nothing but due date minus expected date upon standard deviation. So 2.33 is due date minus expected date is 20 weeks upon standard deviation. Standard deviation is 1.05. Hence 2.33 into 1.05 plus 20 will give you the due date. Right? So when you multiply this, you will get this answer as 22.45. Due date is 22.45 weeks. Right? So the project will be completed on time. The probability, 99% probability that the project will be completed on time. Probability project duration for 99% probability. Project duration for 99% probability is 22.45 weeks. So in there's 99% chances that the project will be completed in 22.45 weeks, right? We'll stop this here for the day. Thank you very much.